How's it going, everyone? Alrighty, so I am doing, from WebWork 4, I'm going to be doing homework problem number 16. Alright, so I already did this problem with my screen record on my iPad, and I thought that it recorded my voice as well, but it doesn't. So I will be doing the voiceover right now. So we have a problem. The drug is administered intravenously, and it's going in at a constant rate of R milligrams per hour. So we need to set up a differential equation for the quantity Q. So that's going to be dQ dt, because obviously it's going to be per time. We're going to be looking against time here. So dQ dt, so R is the rate going in, and then it's proportional to the quantity already present. So that's going to be Q, and then times it's proportional with the constant of proportionality. So we have R minus QK. So that is, again, the amount going in the body minus the amount excreted at a rate proportional to the amount that's already in the body, which is Q. So now we can solve this differential equation, and all we have to do really is just kind of get that other side, turn that into a product, so we can bring the Q over to the other side and separate the variables. And by that, we are going to, let's see, I'm not exactly sure. I believe I divide by, so I basically take out a negative k, I believe, which is going to basically just divide the R by negative k, and then that'll just be plus q, basically. So it's going to get rid of the negative sign there on the qk, and obviously the k too. It's going to divide out the k. So yeah, let's see. We have, okay, so yeah, the negative k times negative k, of course, on the bottom there, and plus q. Okay, so now we have a product, so now I can bring q over to the other side. So basically we can divide R over, so we can divide out the R over negative k plus q, and also at the same time multiply by dt. Okay, so here I just neaten things up a little bit. So we can divide over the q minus rk, and also simultaneously multiply each side by dt, and that will result in dq over q minus rk equals negative k dt. And so, let's see. So I am, okay, so so I add the negative, okay. So there we go. So we have our dt on the other side. So after that, you're about ready to take the integral on each side. Everything's all separated, so it's just going to be 1 over q minus rk dq equals negative k dt. Okay. So there's that. So on the left side there, we're just going to have ln q minus rk. Of course, it's going to be the absolute value. And that's just going to equal negative kt. And then, of course, the plus c, constant of integration. And then from there, we can just take the exponential of each side, which, of course, will negate the natural log there. And we will have q minus rk equals e to the negative k plus t. And then, of course, that can be rewritten as e to the negative kt multiplied by e to the c, because that's just an equivalent way to write that. And then, of course, we can write e to the c as just another arbitrary constant, because it's just a constant itself, which I designate as, let's see, what do I designate that as a there. And so now we can get q by itself, if we just add rk. So then we would have q equals rk, q equals rk plus e to the negative kta. So yeah, we have q equals rk plus, yep, a e to the negative kt. And then from there, we can solve for a. And of course, the original equation says that there's no drug in the body initially. So at time t, the concentration is 0. So q of 0. Let's see here. Q at 0 equals rk plus a e to the negative k, and then t is going to be 0. And then from there, q0 is 0. So that's going to equal kt plus e to the 0 is 1. So then basically we'll just subtract rk over to the other side, and we'll have a equals r over k. So then we can just plug that back into q there. Plug our a back in, and then we'll have rk minus rk e to the negative kt. And that is it. So so now we're going to be able to find, so now we can look at the limiting long run value of q. That is just when we, okay, so, alright, so we can take out the r over k factor as well, 1 minus, yeah. But then, alright, so then we can find the limiting long run value of q, which is basically just where we're just gonna find q at infinity. And so q at infinity is just going to equal rk times 1 minus e to the negative k to the infinity, and e to the infinity is going to equal 0. So basically we're going to have 1 minus 0, which is 1, times rk, which is just rk. So yeah, you can see me do that right there. Plug in infinity for t. So then q at infinity equals rk 1 minus 0. And there we go. So then q at infinity equals rk then, for the long run. Alrighty, guys.